Okay, so the 2014 question on expected value and Bernoulli Trial. So two different games of chance shown below can be played at a charity fundraiser. In each game, the player spins an arrow on a wheel and wins the amount shown in the sector that the arrow stops in. Each game is fair in that the arrow is just as likely to stop in one sector as in the other sector on the wheel. So all of these sectors have the same size of an angle. John played game A 4 times and tells us that he has won a total of €8. And how many different ways could he have done this? So this is a fairly basic approach to take at it, but it's a perfectly valid one. Just list out all the ways that he can win a total of €8 having played it 4 times. So the only real numbers that are of use are 0, 0, 3 and 5, because it's a combination of 2 of those that will get you €8. So you can just list them all out. So they're all different arrangements of these 4 numbers. Another way of doing it, maybe maybe not as obvious, but there's 4 numbers available, and if you have a combination of 2 of them to get the total of €8, then it's 4 choose 2, which would yield you 12. So 12 ways. Now if we just go on to B, to spin either arrow once, the player pays €3. Which game of chance would you expect them to be more successful in raising funds for the charity? Give a reason for your answer. So this is pretty much just an expected value question. So which game, so if we want it to be more successful in raising funds for the charity, then it's the game that pays out the least amount of money, because you're not going to get rich, or you're not going to make a lot of money if you're handing too much of it over. So work out the expected value for each game. If we look back at game A, the outcomes are 5, 0, 6, 3 and 0, and they all have the same chance of happening. So there's 1, 2, 3, 4, there's 5 sectors. So each outcome has the probability of 1 over 5 of happening. So we have, remember the expected value is the sum of all the outcomes by the probability. So the outcome 5 has a 1/5 chance of happening. The outcome 0 has a 1 over 5 chance of happening. The outcome of 6 has a 1 over 5 chance of happening. The outcome 3 has a 1 over 5 chance of happening. And the outcome 0 has a 1 over 5 chance of happening. Now, summing all those together, because remember that's what the expected value is, game A yields an expected value of €2.80. So that's game A. Game B, it's a similar calculation. And if we look at game B, the outcomes, this time there are 6 outcomes, 5, 0, 3, 1, 4, 2, and each outcome has the same chance of happening. So the outcome, so starting from €2, that's got a probability of 1 over 6, plus €5, probability of 1 over 6, plus €0 multiplied by the probability of it happening, €3 multiplied by the probability of it happening, plus €1 multiplied by the probability of it happening, plus €4 multiplied by the probability of it happening. And when we sum all of those up, we get €2.50. So it's game B. Game B would give us the best chance of raising more funds for charity, because when it's played more often, it will pay out less money. Now the last part of this question is a Bernoulli Trial. And we can see that Mary plays game B 6 times, find the probability that the arrow stops in the €4 sector exactly twice. So this is a Bernoulli Trial, because there's really only 2 outcomes. Success is stopping in €4, and failure is not stopping in €4. So n choose r, p to the power of r, and q to the power of n minus r. Remember that n is the number of trials. So in this case, n is 6 because she plays it 6 times. We're looking for it to stop in the €4 sector twice, so 2 successes. P is the probability of success, which in this case is stopping in the €4 sector. So we're in game B. There's one €4 sector in game B. So the probability that it stops in the €4 sector is 1 in 4, or sorry, I beg your pardon, 1 over 6. And the probability of failure, i.e. that it doesn't stop in the €4 sector, is 5 over 6. And then N choose R is simply the number of ways it could happen. You could stop in the €4 sector in your first 2 goes, or your last 2 goes. So plug the numbers into the formula. So we're playing it 6 times. We're looking for 2 successes. So 1 over 6 is the probability of success. We're looking for 2 successes. We're looking for 4 failures, so to speak. And when we plug all of that into the calculator or into the formula, we get about 0.2. Now it doesn't give me any indication here as to how many decimal places, but so I'm just rounding it off to 0.2. Any questions? Send me them on.